Coming up next, we have Mike Russos, and Mike is going to talk to us about how we can collect ASP.NET Core performance traces with a Kubernetes cluster. So that sounds really cool. So Mike, why don't you go ahead and take it over?
All right, absolutely. Thank you very much. So yeah, I'm Mike Russos. I'm a software engineer on the .NET Customer Engagement team, and we're going to be talking today about tools you can use to collect performance information on your .NET apps in Kubernetes. And so we'll jump right in, look at some of the tools. And I should point out, even though this is called ASP.NET Core performance tracing, because that's usually the type of app you're going to have deployed in a Kubernetes cluster, there's really nothing here that's ASP.NET specific. These tools work on .NET Core. So there's a variety of tools that you want to look at when you're trying to understand the performance of your app. The primary ones you're going to want to use are the .NET CLI tools, things like .NET Trace, .NET Dump, and so on. I've got those listed here. If you're not familiar with them, just briefly, the way these work is you use the .NET Core SDK to install them, and then from the command line, you can run them as .NET CLI tools, and they gather information on the processes that you're running. So .NET Trace is useful for collecting performance traces so that you can understand where your app is spending time. You can understand things like how often the garbage collector is running. You can see perf counters for information on threading and so forth. And so that's a really useful one. Another tool that complements it well is .NET Dump. .NET Dump allows you to capture a dump of a process so that you can see the heap and what's happening in memory. You can look at sort of where the call stacks are for each thread when the dump was captured. You can see exception information. And so that's kind of the second one that we use a lot when we're debugging issues with customers. A variant of .NET Dump is .NET GC Dump, and the only difference between them is that .NET GC Dump only captures the heap information, so all you see is what's happening in managed memory. But the benefit you get from that is that those dumps can be analyzed cross-platform. So you can take a dump that you captured with .NET GC Dump, and you can open it up on a Windows machine using Visual Studio or whatever tools you like. Whereas with .NET Dump, you get the broader context of the app. You get the managed memory information. You also get call stacks, exception information, and so on. But you have to analyze those dumps on the same operating system they were captured on. So those are sort of the differences there. And then a couple other tools, .NET Counters will show you sort of perf counter information live. So this can be a useful first tool to run when you're analyzing a problem, because you can run it and will show you things like, in addition to just like CPU usage and memory usage, it'll show you .NET specific information as far as thread pool count. It'll show you different GC generation sizes. You can get information on ASP.NET Core response times. And so it's a good way to sort of look at a dashboard and understand at a high level how an app is performing. And then an interesting one that a lot of people don't know about is .NET Monitor, which is new. It's still in preview. So this isn't quite ready for prime time yet, but it's in the works. .NET Monitor will set up HTTP endpoints in your Kubernetes pod so that you can query them to get these sorts of diagnostic artifacts. So once you've got .NET Monitor running, you can make an HTTP call to request a dump or to request a performance trace and so on. And so again, this one's still in preview, but you know, if we've got a blog post, which has been out for a number of months, so some folks have probably already seen it, but we'll keep you posted on the .NET blog as this evolves. So you can sort of look at this as another option. I'll just move this back over here. So those are kind of the primary tools. Now, in addition to the CLI tools, you may also need to use things like perf collector, create, dump. And these tools are a little bit more challenging to use in a containerized environment because they require elevated permissions, which isn't always something you want to do in your Kubernetes cluster. But these tools have the benefit of also capturing native information. So all of the CLI tools can run easily without having to be elevated, without any special environment variables, but they're only going to capture the managed state of your process. If you use something like perf collect, that's going to be analogous to .NET Trace. So you're getting information on performance tracing, you're getting your perf counters and so on, but you're going to need elevated permissions to do that. Similarly, create dump is analogous to like .NET Dump, but it has the benefit of getting both managed and native call stacks and memory information, but it has the downside of requiring elevated permissions, which may be problematic depending on your environment. So these are a lot of tools. I'm going to kind of go over some of the pros and cons of each of them in more detail, and then we'll do some demos and show what it looks like to use these in a Kubernetes environment. Oh, also, I have this environment variable com plus debug enable mini dump. That can be useful because when you set that environment variable, it informs create dump that you want to automatically capture a dump anytime a managed process crashes. So if you have some sort of intermittent crash that's killing your containers, you can use this environment variable to have create dump automatically capture dumps for you when you hit an exception. So those are some of the tools that we're going to be looking at, and some of the ones that if you're not familiar with, you want to go search for. We've got docs for all of these on docs.microsoft.com, and you just want to familiarize yourself because these are the best tools for understanding what's happening in your .NET Core process. Now, when we talk about using these specifically in a containerized environment, there are some specific challenges we want to keep in mind. One of them is deployment. Because the CLI tools are installed with the .NET Core SDK, it can be a little bit tricky to get them into your containers because typically your production containers won't have the SDK installed. You'll just have the .NET Core runtime. And so you'll want to think about this ahead of time. In some cases, you may want to actually install the tools when you build your Docker image, that they're all ready to go in case you need them. Just having the tools present won't slow anything down. They will make your Docker image larger, though. Each of the tools on this slide, .NET Trace, .NET Dump, so on, they each take about 10 megabytes. .NET Dump actually is the outlier. It's 50 megabytes. All the rest are 10. This one's 50. So you want to bear that in mind because depending on how sensitive you are to image size, that may or may not make sense. If you don't install the tools ahead of time, you'll want to be able to copy them on as needed. So to do that, you'll typically spin up another container using the same base image. So you make sure that you've got the exact same image of .NET Core so that you've got the same OS underneath, but you'll have the .NET Core SDK in this image instead of the .NET Core runtime. And then you can install the tools. And once they're there, you can just Xcopy deploy them. I'm going to show you that. It's very easy. You just copy the binaries. But because they're typically installed with the SDK, it's a couple extra steps. Okay, and so that's going to apply to like .NET Trace, .NET Dump, things like this. For some of the other tools, they're easy to get on there. In fact, Create Dump comes with the .NET Core runtime, so it's already in all of your Docker containers, whether you knew it or not. The challenge with these ones is you have to run with elevated permissions. In the case of perf collect, you have to have some environment variables set. So I'm going to walk through this in more details, but those tools often will require you to restart your container with different privileges or with different environment so that they're going to work. So they're easier to get on the box, but they're a little bit trickier to use. So just kind of walking through these in more detail here. When you're talking about collecting a performance trace so that you can understand where time is being spent, maybe you've got a bottleneck, maybe you've got high CPU usage, the two tools you want to look at are .NET Trace and perf collect. And I've tried here to sort of summarize why you might choose one over the other. Again, .NET Trace is going to be the recommendation typically because it's the easiest to use. You don't have to have any sort of special privileges. But the downsides are that it's managed only. You can't use it with .NET Core 2.1. And if you were to try to use this from a sidecar container, which is another scenario I'm going to talk about, running from a sidecar container, all of the .NET Core CLI tools like .NET Trace, .NET Dump, and so on require access to the temp directory of the container where the .NET process is running. So if you don't run .NET Trace in the same container as the app, you're going to have to make sure that the temp directory is shared between your containers so that it works. Perf collect, on the other hand, like I already alluded to earlier, is going to give you even more information because it shows you both managed and native portions of your app. It, in fact, can show you multiple processes at the same time. So if you have a cross-process perf issue you're trying to track down, you probably want to use perf collect. But you're going to need to be running with sysadmin capability, which I know some folks don't want to do in their containers. There's also a couple of environment variables which need to be set before your .NET Core app starts. So you may need to restart the app or restart the container with different environment variables if you need to use perf collect. Similarly, if you're going to be using .NET Dump, .NET Dump, .NET GC Dump are sort of the recommendations here, again, because of their ease of use. If you can use them, this is what I'd recommend you go with. And again, the only difference between .NET Dump and .NET GC Dump is where you can analyze the dumps and how much is contained in them. But if you need to fall back to create dump because you need to see both managed and native portions of the process, that's an option, and it's super easy to deploy because it's already present. But now you need to make sure that your app has, or your container has started with sys ptrace capability. So that's something that you sort of need to keep in mind when you're using those tools. So again, these are the tools you'll want to be looking at. These are some of the things you want to keep in mind. And I want to spend the bulk of our time here just sort of walking through them to show you what it looks like using these in a real world environment. So I'm going to switch screens here over to my my terminal, and we're going to test these out. I've got a Kubernetes cluster already deployed. So if I do a git pods, you can see I've got one pod running with 2 containers, just called test app. It's not running anything interesting. It's got an ASP.NET Core 3.1 app. If you were to do this with .NET 5, the story is exactly the same. I'm using 3.1 because it's an LTS. A lot of our customers are still on, but .NET 5, newly released, awesome, really exciting, and definitely worth checking out. The process is going to be identical, so you don't need to worry whether it's 3.1 or 5. Anyhow, the app is just a simple ASP.NET Core app with a background service just running in the background, eating up some CPU, so there's something to look at in a trace. Okay. Now, because we don't have something like .NET Monitor out of preview yet for us to do this remotely with HTTP requests, the easiest way to profile is just to exec into your container, exec into the pod, and run the tools locally. So in this case, if I wanted to collect a performance trace, I would just do a kube control, exec, and make it interactive, and then I give my my pod name. And because this pod has multiple containers, I need to specify that I'm going into the test app container. And then we'll just jump into a bash shell and go from there. Now, in this case, it's going to be really easy for me to run .NET Trace because it's already present in my container. That's because I sort of did the hard work ahead of time by making sure when I built this image, it already contained .NET Trace. So let me show you that. This is my Docker file. Most of this is going to be a super standard Docker file for an ASP.NET Core app. We've got our base image, which is just based on the ASP.NET base. We then have our build image based on the .NET Core SDK, where we do things like restoring, building, and then publishing our app. And then we just copy it over into that ASP.NET runtime image. So that's all pretty boilerplate. The thing I did that's different here is that we're running .NET Tool install on .NET Trace and some of the other ones in case we wanted to use them. And this is the thing that's extra here. And if you can spare 10 megabytes in your Docker image, it's sometimes worth dropping in .NET Trace or maybe even .NET counters so that they're there if you want them. Because since our build image has the SDK present, we can do this and it installs the tool. Then once we're publishing, we just copy everything from the tools directory into our runtime image, into our final image, and they're all ready to go. Because like I said, installing these tools is as easy as copying them. So if I come back over here and we go into that tools folder, let's see, what do I call it? Tools. Now it is important that you look at all files, not just what's visible, because if you just do an ls, you'll see .NET Trace, you'll see this exe here, but that's not the only thing you need to copy into your container. When you install the .NET CLI tools like .NET Trace, .NET Dump, and so on, you get the exe, like .NET Trace, but that's just the entry point. There's also a .store directory where we've actually got a lot of implementation details. So whether you're doing this when you build your container, or if you're going to do this after the fact and install the tools in a separate container or on a separate Linux machine and then copy them over, make sure that you're copying this store directory also, because that's necessary for the tools to run. But having got the tools onto the container, that's really the only hard part with the CLI tools. Once you've got them in your container, as long as you're only looking at the managed portion of your process, you're good to go. You can run them by just doing a .NET Trace. Maybe start with PS, so it'll show us all of the managed processes that we could profile. Okay, we see process ID number 6 is my .NET process, so that's the one I want to collect a trace for. So I'm just going to do a .NET Trace collect, and we'll do it on process 6. So we do that, And now it started collecting. So at this point, it's profiling the app. It's getting information on how much time's being spent. It's collecting perf counters and so on. So at this point now, we would apply load to our site, make sure we're hitting the interesting code paths. Usually once you've got 20, 30 seconds of a trace, that's going to be sufficient as long as you've got interesting traffic coming in. So at that point, we can hit enter or control C to be done. It finishes up, zips everything up, and now we have this trace.net trace file, which we can open in Purview. Now, one of the drawbacks to doing this on Linux is that you can unzip this and pull out some stuff that you can analyze with the perf tool in a Linux environment, but the best way to analyze these is using Purview, which is Windows only at the moment. So in order to analyze this trace, we're going to jump back out of our container, and we're just going to copy this locally. So we'll do a kube control copy, and we'll copy from the test app container. It was in tools, trace.net trace, and we'll just put that here in a folder I've got set aside for that. And again, because I've got multiple containers in my pod, I specify that this is coming from the test app container. So we do this, it copies the performance trace from my cluster locally. Now I'm on my Windows machine, I can run Purview, and we can go ahead and open it up. Now, if you're not familiar with Purview, it's definitely worth learning. It's a very powerful performance analysis tool. It's been around for a while, so folks who are coming from the .NET Framework side may have some familiarity with it. But you can go out to github.com/Microsoft/Purview. It's all open source now. And we've got some links there to tutorial videos, some useful blogs. So if you're not familiar with the tool, definitely go check it out. It's worth learning. And I'm not going to dive way into this because I don't want to get too sidetracked from gathering the data, but you would bring this over here, you'd open it up in Purview, and now we have access to the various events that happened. We've got our stacks, so we can come in here, try to figure out where we're spending. Let's look at our CPU time, perhaps. We'll drill into that, look at callers, and pretty quickly we start to discover that, there is, especially if I take off the filter, it'll be more obvious. See in here that we've got something called spin service, spin for a second. This is an API that I have running as a background service in my app that's just continually checking the date time and waiting in a tight for loop. And it's really just burning CPU. But that shows up in here because we've gathered this performance trace. So that's one option. The other option would be to use perf collect, which I want to move on to the dump debugging because I want to make sure I cover that one as well. But perf collect ends up being similar, but you have to make sure that you're running with a couple extra permissions. And we'll see that also with the dump debugging. So we'll get a little bit of that in a minute. So let's take a look now at how, if we wanted to gather a dump for that process and understand what was happening on the heap, or to look at specific call stacks. So for that, again, we can go into our Kubernetes cluster again. We can exec in. Now this time, I could go into the test app and I could use .NET dump because I've got that tool there. But let's suppose that we want to use create dump because we want to see both managed and native memory. And we want to get that broader view. Or this would be the way you would do it if you wanted to run perf collect, if you want to use one of these native tools. In that case, we could jump back in where we were. In fact, I'll do that and I'll show you what happens. But it's not going to work because it needs additional permissions. So if we come in here, and now, again, the one nice thing about if we use create dump to get a dump is that it's already present. So if I just take a look, let's see here. If we copy this path, make sure I get it right. If we look next to the .NET Core runtime, create dump's already there. So we just go to user share, .NET shared, your runtime folder, the version. The create dump's already present. But in this case, we're not able to run it because we're not running with proper permissions. So even if I do this, we get permission denied. So what we can do here is we can run it from a sidecar, or we could just restart this container with elevated permissions. So let me show you the way I set this up in the Kubernetes manifest, because that's going to be sort of interesting. So we already looked at the apps Docker file. The other one that's interesting is I've got this sidecar Docker file. Now this one, it's just based on the .NET Core SDK because we're not worried about it being small. I've installed perf collect already. So if you wanted to do that, installing perf collect is as simple as just curling down the script, making it executable, and then running perf collect install. And this gets perf collect ready to go. And I'm also installing the .NET Core CLI tools, so I've got them there if I need them. But the interesting part is really in the Kubernetes manifest. So in here, this is a fairly standard Kubernetes manifest deploying my app. You know, we've got test app, and we've got the port, we've got some resource limits. The things that are interesting are that I've also included this sidecar. And now with the sidecar, I've also added the security context section with certain capabilities. And I'm running it with the sysadmin and sysptrace capabilities. And that's going to give this sidecar container the ability to do some things that our normal app container can't. Sysadmin is going to let it run the perf tool, which perf collect is using, and sysptrace is going to allow it to use create dump to capture dumps of any processes. Now, also, when I set up this pod, I've made sure that I'll specify share process namespace is true, and that's important because that allows my sidecar container in the same pod as my target app to see those processes, see my .NET processes, and profile and debug them from a separate container. So because we've got shared namespace, shared process namespace is true, and because we've got elevated permissions on our sidecar, we're able to actually now exec into that sidecar container and use tools like create dump, or if we wanted perf collect to profile. I'll also call out that I do volume mount the temp directory. This is not something that we'll likely see in this demo, but if you wanted to use the .NET CLI tools from a sidecar, like I said earlier in this talk, you need to make sure that your temp directory is shared between the sidecar container and the test app because files get written there that they share. So that's why those are have that. So having shown this, we can jump back over here and let's go ahead and run create dump just to show what that looks like. We could do .NET dump as well, but it's basically the exact same experience as .NET Trace, so it's not terribly interesting. So we're going to exec in. This time I'm going to exec into my sidecar. And again, it doesn't have to be a sidecar. You could use the target app itself. It just would have to have those elevated permissions. Something that's worth keeping an eye on, and I think I actually had this on one of the slides, is ephemeral containers. Ephemeral containers are only in alpha right now for Kubernetes, and they're not available in AKS. But in the future, ephemeral containers will allow you to, on the fly, add a container to an existing pod for debugging purposes. And this is like exactly what we want. So it's not ready to go yet. You can't do it today. But as this comes out of alpha and gets support in Azure Kubernetes Service, kind of the dream state would be that you don't even have to put anything special in your production container. Instead, you could add an ephemeral container to its pod as needed and run these tools from there. So if we do that, let's come back over to this window. I've execed into my sidecar. And so from here now, we're able to actually run some of the tools like perf collect and create dump that didn't work in the other container. So we'll go to user share .NET Microsoft. Let's see. Oh, sorry. Shared Microsoft .NET Core app version and create dump. And this is a super simple tool to use. It sits next to the runtime, and you just provide it with the process ID of the process that you want to capture a dump for. So we do that, and it takes a couple of minutes, or maybe not, it takes like a few seconds, but it's going to now write that dump to dump temp/core dump.6. We can analyze it using .NET dump. The .NET dump CLI tool is both able to capture dumps and it's able to analyze them. So we can analyze it with .NET dump, or if we wanted, we can copy it to some other machine. Now, you're going to want to use a Linux machine to analyze the Linux dumps, unless you did .NET GC dump, which is sort of its selling point. But that's fairly easy to do. just very briefly, and then we'll sort of move over and see what sort of questions folks have. If we were to copy from the temp directory, it's called, let's see, core dump.6, and we'll just put that in our traces folder also. And let's see, we have to specify the container name. This will take just a minute to copy over because the dumps are sort of large files. But once that's copied over, we can debug it either with .NET Dump, or you can use LLDB as a Linux debugger that's good for debugging dumps that are captured from Linux operating systems like Ubuntu or whatever. And so let's see if that's copied yet. So it's still copying. But what you'll want to do is you'll first use the .NET symbol tool to make sure that you've got all of the files you need. And we've got docs on this as well. So again, if you go out, if you search on the internet for Linux dump debugging .NET Core, it'll take you to our Microsoft documentation where we explain this process in more detail. But basically, you use .NET symbol to make sure that you've got the DAC, the core CLR, the various things that you need, depending on where that dump was captured. So I'll do that first. So now it downloads a handful of files, because when you open up a Linux core dump and want to debug it with managed debugging, you need to have the DAC, the host, the core CLR. And so this .NET symbol tool will actually download all of those for you. And actually, I tried it before the dump file was copied, so it failed. But now the dump file is actually copied, so we can do this. We'll copy these files down. Should only take just a short time here. And then once you have those locally, you're able to just use LLDB and SOS to actually open it up. Okay, so we've downloaded the core CLR, the DAC, DBI, and the host. So then at this point, we'll run LLDB, we'll give it our core dump, and we'll give it the host, which is .NET. Now you're able to use SOS commands the same way you would have in WinDBG or something like that previously on Windows. So you can do things like dump heap .stat to see everything that's on the heap, for example. And this will show you, there we go. Now we can see that strings and bytes are taking up most of the heap, as always. But anyhow, I know this was a super quick demo. There's a lot to cover in this topic, but I just kind of want to show you what's out there. And again, we've made a real concerted effort over the past few months to beef up documentation on these tools. So if you want to dive in more, just go out to docs.microsoft.com, search for debugging in containers or Linux debugging on .NET Core, and you'll get docs. But these are the sorts of things that you'll be looking at, and hopefully this gives just a kind of brief idea of how they work. So with that, I haven't been watching the chat window. Let's see, do we have any questions?
All right, thanks, Mike. We do have some questions for you.
Okay, awesome.
So let's head over to the tag board. And this one's from Robert Emmett. And Robert is asking, can .NET counters be used as an equivalent way to use Win performance counters in Mac or Linux environments? I'm assuming it uses event counter APIs.
Yes. So .NET Counters works cross-platform. It doesn't actually use perf counters since they're Windows only, but as you point out, there's event source event counters, which are in .NET Core, the cross-platform replacements. So .NET Counters works everywhere. In fact, well, I don't want to spend too long on this one. So the short answer is yes. If we run out of questions, I'll demo .NET Counters. But yeah, absolutely cross-platform, and it's a useful replacement.
All right, great. So that was our only question, but we do need to move forward and head over to the next speaker that's coming up really quickly. So Mike, thank you so much for coming on and sharing your stuff with us. And, folks are on Twitter. If you head over and you check out the hashtag .NET Conf, there's tons of questions that are on there. So, definitely please head over there. And, if there's any additional questions, please make sure you, give everyone some attention.
All right. Yeah, absolutely. Thank you very much.
All right. Thank you so much, Mike.